now move into our moon-based design contest entrance. So the Society held a moon-based design contest last year. We got 18 high quality entries in, and we awarded 3 different prizes to the entrants. And the winning prize was to the Space Generation Advisory Council, and their moon base was called Domi Inter Astra. And I'd like to bring on the 3 presenters for that now, James Z, Nietzsche, and Sajal. You guys can turn your video on. All right, nice to see you guys. Welcome to the Lunar Development Conference. We'd love to have you guys present your winning design for the Moon-Based Design Contest.
Yes, 1 second, let me just share my screen. All right. Good morning, everyone. We are Nitya and Sejal from a team of 18 students and young professionals who are part of SJAC's Moon-Based Design team, and our lunar habitat is Domi Inter Astra, a home among the stars. So without further ado, let's dive into the specifics of our design before opening for questions. The first area we'll be covering is engineering. And the first question we should ask is, where will we be building our settlement? We decided to locate our base close to the Shackleton crater. Point C marks the habitat location in a flat region, and point D is the landing site about 1 kilometer away to provide a sufficiently safe zone. What are points A and B? Where the solar panels are located. Our power system consists of solar panels with backup batteries, and points A and B were specifically chosen because collectively they are lit almost 94% of the time. This helps minimize battery needs. 2 satellites are selected for communication, and they relay information directly to the deep space network. And we also have rovers to use for construction and exploration. And now we've seen where it's located, but what exactly is at point C? Let's take a look. So these toroid shapes are what the modules of our settlement look like. As seen in the picture, this helps us to maximize the usable area and improve the efficiency of transferring vibrational loads to the ground. The steel structures internally act to support the regolith in case of depressurization, and to minimize the regolith required, we will collect the regolith from the bottom of the site and pile it on top, and the toroid itself will be buried till the entrance. And we'll be covering each module with around 3 meters of regolith for radiation shielding. The top and bottom spaces are used for storage, wiring, etc. And we have aluminum I-beams to hold the structure in place from inside. Now let's take a look at how all of these modules are connected together. This image here shows the technical layout of the base. Equipment is installed in the ceilings and floors and concentrated above and below walkways, and critical life support systems are present in every module. We also have LAN to allow communication between all the various modules. This layout was driven by the types of hazards and the accessibility for maintenance, and minimizing the storage required while maximizing the habitable space to make it more comfortable for all the crew and the tourists. Now, there's some important factors to living on the moon, and those are food, water, and air. So let's take a look at how those work. This image here shows the air and water systems, and the flow rates are estimated from ISS and NEAR. Clearly, our air-water system utilizes the ISS model with some upgrades, and sufficient air is always on hand in case of any emergency. Food and the human waste recycling is an integral part of the space, and greenhouses and fungi culture are maintained in a phased approach so that eventually the base can provide itself with fresh food. Plants support closing the life support loop by recycling human waste. The thermal systems also use an ISS-like system to reject heat from the settlement, and the regolith also provides sufficient insulation. So far, we've seen the modules, how they come together, and what systems drive them. But how are we actually going to implement all this? This is the execution timeline for our base. As you can see, it's divided into 3 phases, utilizing 4 rovers. The design phase is able to begin immediately as critical technologies are flight proven and new technologies are already in development. A phased approach for expanding into the final configuration allows the gradual size of gradual growth of crew size, capability, and exploration into the Shackleton crater for ISRO operations. The exact timeline is not, the exact dates for the timeline are not estimated, as the entire process is labor driven. So, so now we will move on to architecture. And the architecture is an integration of systems drawing inspiration from Earth. This is the main floor plan of our base. There are 5 modules, like I've talked about before, and I'm going to be delving into each of this in the subsequent slides. The first module is a greenhouse, guest amenities, medicine, and environmental control module. This is the primary entrance to our lunar settlements, and guests and new crew upon arrival are greeted by one of the largest greenhouses, which will provide a familiar sight to help guests relax and acclimatize. We've taken into consider tiny details for the well-being of the crew on the base. The furniture is designed to use lightweight composites that are foldable, portable, and modular to allow easy repair. Wood prints also provide a warm atmosphere to help connect the crew to Earth. Here, in the next few slides, we'll be looking at few of the renders that we created for our base. While they're not, they don't fully reflect, we hope to convey how our base looks like through these renders. This render here talks about the social module, and this is the central module where all the fun happens, and crew members and tourists can socialize together, relax, and recharge. We also have a little cupola in the third module looking out into space. Viewing the Earth, the lunar landscape, and the night sky is one of the main tourist attractions. The fourth module is the crew bedrooms and a private social space. As seen in the image, crew quarters are personal spaces for the crew to relax, and guests and crew bedrooms are split to minimize disruptions and provide more personal space. The lighting is dimmer and encourages sleep. They also have their own storage space, and there's Velcro on the wall to allow them to decorate it as they wish. The final render we have is of the workspace. Crew time is clearly prioritized towards activities that can only be done on the moon. The airlock is also located in this module to allow crew to bring in larger equipment that cannot fit inside the rovers. Now I've talked about engineering and architecture aspects of our report, and now I'm going to hand it over to Sejal to continue.
Thank you, Nitya, for handing it over. Good morning, everyone. My name is Sejal, and I'll be talking about the economic section. Next slide, please. To make this slide and the settlement economically feasible, the project needed to be as low cost as possible and have as much revenue generation capacity. Here we have in the total life cycle cost, we've considered the maintenance cost, the total investment cost, the operating cost, as well as the sustaining capital. Here on the cost side, we tried to minimize the initial capital by minimizing the launch mass and the launch volumes. Getting public support to rapidly construct the settlement and begin operations will also drive down the cost. Once operating, our focus was on minimizing resupply costs. When many technologies are simplified on the moon, we have added as many new systems as possible so that the capital to sustain the settlement may be higher. Now that we've discussed the settlement cost, let's move to the revenue generation. Our revenue generation is unique in the fact that it does not focus on just capital, but also on gaining public support. There are many revenue streams that were identified with the goal to have a diverse portfolio of sources that could begin as early as possible in the project life cycle. While some of the streams are dedicated to generate monetary funds, such as the ride shares, the payload and infrastructure sharing, as well as the crew allocation and services, there are some dedicated to gaining and maintaining the public support, such as the branding and naming rights, tourism, education, and outreach. A moon settlement also opens opportunities for new industries to develop and compete in the Earth markets, which is what we hope to contribute to. Next slide, please. Since we've actively looked at the economics, let's now move on to the management and the politics of the base itself. Our goal here was to establish and provide a chance for non-spacefaring countries and civilizations to gain expertise on the lunar base, which is why we went with the polycentric model, which was one of the best ways to achieve collective action. As you can see here in our polycentric governance, we have the main investors, observers, advisors, and the settlement crew, which are not limited just to the crew, but also open to tourists, which I will be delving on to further. And we have the home institutions, which delve into operations as well. Our primary policymakers are the bodies that invested in the settlements, private service providers, and states that are not actively invested but are involved in the operations of the settlement will allow their own spheres of influence. Next slide, please. We delve into the overall governance at the macroscopic level. Now, moving on to the microscopic level, we have the cruise schedule. The crews are split into 3 shifts that ensure constant settlement and monitoring, improving the crew and the Earth relationship, and to maximize the utilization. What we've tried to highlight is the importance of maintaining schedules while actively ensuring leisure activities are conducted for the crew and the tourists as well. Next slide, please. As we move to society and culture, which is personally one of my favorite bits, is because it represents the international collaboration that DIA officially represents. Next slide, please. As you see from our logo, Domi Inter Astra, DIA stands for all humanity. We believe in safety, collaboration, exploration, curiosity, and equality. And these beliefs are highlighted in our laws and the ideal culture of DIA itself. We have space for conversations and sharing of cultures. Visitors can come from any nations as tourists or crews. English will be the main operating language, and we have no set faith or religion. This promotes the STEAM segment that we highlight and focus on. Next slide, please. I have spoken about tourism earlier as well, and spoken about how we believe in international collaboration. How we would want to make it possible is through the tourists visiting the settlement to be shadows of the crew, to view the research and the development activities, as well as be actively contributing to the revenue generation, the tourism, and the outreach of the base itself. They would get to experience life in another world and potentially participate in groundbreaking studies. And I hope to see all of you there someday. Next slide, please. The tourist selection will be managed by the institution for training the tourists itself. However, to make it as authentic as possible, a lottery system will be used to distribute the cost with more frequent draws as these costs decrease. Next slide, please. Now that we've talked about the tourist selection, we hope to make this base a reality. And going forward, our project is continuing in various forms from individuals all across the world. A discussion of the gaps and roadmaps towards addressing them will be presented in the International Astronautical Congress in 2021. And currently, a book is under development which expands further on the design report to look at space exploration through STEAM lenses. Thank you, everyone, for taking out the time for listening to us. And we would love to hear any questions.
Okay, thank you, Team DIA. Any questions from the audience? I have one question. Can you talk a little bit more about how you would fund the base and how the base may generate revenue after it's built?
I can hop in on that one. So hello, my name is James. In terms of funding the base, right now, as it is, it seems like for such an expensive project, it would need to be partially government funded or entirely government funded. But we do find that there's a lot of opportunities to involve private industry as well. So I don't know if Nitya, if you can flip back to the revenue generation slide. What we have in mind is primarily public-private partnerships to develop key technologies and deliver on specific scopes of the project. And then as we construct different parts of the settlement, we try to prioritize building entire scopes at early on so that we can start using parts of our settlement for various purposes while we continue building the rest. So it would start generating revenue as early as possible using whatever we have built. So any small infrastructure. And then as we continue to expand the scope to the full settlement design, we would continue to generate more revenue by selling more services.
And obviously tourism is going to be a component of that, as I see on this slide. How would you market your base to tourists?
If you can flip to the tourism slide, yeah. So that was definitely more of a challenge, especially early on, especially with safety. For marketing to tourists, I think out of the group here, if someone told me that you could go visit the moon at a reasonable price, that would be definitely something that I would want to participate in. And so the biggest barrier that we see is that it's just going to be too expensive for the average person to go visit the moon. So you sort of have two buckets. You've got the ultra rich, the Jeff Bezos of the world, who can just go if they want to. And then you have the rest of the people around that have some capital, but not quite to take a vacation to the moon. That's what drove us towards this lottery system. And so we would try to distribute the cost as much as we can and offer this similar to sort of, if in Canada, you've got the Lotto Max, et cetera, where people would enter, pay a small fee to have the chance to go to the moon, and that collectively would fund tourism trips. And once you're there, we all have seen sort of images of the moon landing, and as the base gets built, you can see what a space settlement can look like. And so those two aspects we feel would be very enticing to have people visit and physically take a step on the moon.
But like if they have the option to go, like say they win the lottery and they get a ticket to the moon, but there's more than one base they can go to, yours is just one of many.
Right.
How would you market your base to that tourist? Like what are the appealing things about your base over potentially others?
I don't know, Sejal, if you want to add some stuff from the society and culture side, because I think that would really help with the marketing end. But just in general, from early on, our base is intended to be quite diverse. And so we wanted to really embody international collaboration and try to involve as many different countries as we can. And so having someone visit can see the sort of collaborative nature and also the type of work that we're trying to do. And so we try to prioritize as many different scopes of interest at our base, having greenhouses as well. And so the thought of having multiple bases on the moon, what we try to do is try to say, hey, if you want to go to the moon and make a good settlement, come join our cause and build a settlement there. But in terms of the culture there, I think I'll turn over to Sejal to talk about that.
Yeah, definitely. Thanks, James. So what I want to highlight here is that usually when you market a particular product, or in our case, a base to a particular person, it's how they can contribute to it and what they can, what their incentives would be to actually be a part of it. Here we offer people from all across the world to get a chance. Now, usually in the space industry, as we see today, it is quite restrictive and not open to all the nations very actively. So what we hope to do is, first of all, market that we have space for conversations and sharing of cultures. We also have the opportunity for the people and the tourists coming on board to shadow the crew, that is to actually see what research activities take part and also to be a part of those groundbreaking studies. Now, this may be really inciting to like some professors, students, young professionals. But if you're looking at it from like even a tourism point of view, not only do you get to go on the moon, be a part of the WASE and meet people from all across the world, but you also get to contribute to like research studies. And these aren't, again, as I spoke about, these aren't limited to just science and technology. What we hope to do is utilize STEAM. So we also have the arts coming in. And later on, when we develop, we want to, involve and call upon artists to have renderings on the moon bases or paintings or potentially even a museum or artifacts. And I think that's how we make it all inclusive and promote the idea that space is for everyone.
If you have a thriving culture in your base and there's lots of people there, have you thought through how to govern them, how to ensure they have a voice in how the settlement is run?
Yeah, if you can flip over to the polycentric model slide. So this was sort of a governance scheme that shows from a high level from between Earth and the settlement. But our picture here is that starting off, we would want something centralized. We don't know how to operate on the moon. And so having a central authority will really help with understanding the policies and develop the operating schemes that we want. But as we get more comfortable with our settlement, and various parts of the government scheme become more autonomous, what we want to do is open it up as a polycentric scheme, which is shown here, where different aspects of life on the moon, from sort of the maintenance and operations side to the work streams and then tourism, would each have their own governance system based on whatever organization makes most amount of sense. Either it's one government takes that on, a private company takes that on, or an amalgamation that wants to co-govern take that on. But each kind of aspect of life would have their own major players there. And then this actually opens up the opportunity to integrate new members. So let's say we start tomorrow, we have the space superpowers in the world right now who can probably fund this and would likely want a controlling interest in governing the settlement. But as we start operating and we open up more opportunities to be involved, we can then introduce other spacefaring companies or spacefaring nations in who have their niches that they want to help operate. And so in terms of governance there, we want to start opening up that and getting things as autonomous as we can. On the settlement itself with the crew, our thought is for the crew itself, we would still keep a very strict governance system. So you can kind of see here in the crew schedule. And that's because with the crew working there, the time that you have on the moon is quite valuable. You're going to be there for only a limited amount of time. You have so much work to do. And so keeping the more strict hierarchy so that the crew are able to complete their work without having to sacrifice too much of their leisure time feels like that's still necessary to do.
It's good that you scheduled time for them to eat. That's, you know, sometimes people get so busy they forget to eat. And I think having meals together as a crew, you know, in this case, maybe a shift, is really important to maintain that community. Awesome. Don't see any other questions. So I'm going to say thank you to you guys for presenting today. This was a great design, and you know, congratulations again for winning our contest. And thank you a lot for participating today in the Lunar Development Conference.